Hey, welcome to the shop. So now we are going to talk about stick welding. I'm currently in fabrication and I'm going to cover the basics of stick welding. Basically the concepts, the parts, and all that surrounds that. Just to help you out, get you a little more comfortable if you're deciding to take on stick welding. This is also, you know, most of these videos, if you don't know, are for my fellow students. There's a lot out there as far as information, but to hear it come from a student, you know, that's going through the same classes as them, it just helps them out. So, little shout out to all my fellow JTech students. Thanks for watching. If you are watching my videos, I hope they all help you. I didn't have videos like these to look forward to. I did a lot of searching on the internet to try to find other things so that I could help comprehend some of the things going on. So, little shout out to you guys. Anyway, going back into stick welding. Stick welding, also known as arc welding, is basically using electricity in order to weld. So in my one video I was covering gas cutting, basically oxyacetylene. Now you can weld with oxyacetylene as well. You're basically heating up the metal with the torch, and you're using a rod and you're putting the rod in so that it melts in to the heated metal, creating a weld bead. Now, and you really got to work that back and forth. You got to get with that motion. I tried. My line just starts going all different directions. I cannot keep a straight bead worth anything. Probably not cut out to be a welder. but I give it a shot. I try. So with arc welding or stick welding, you're utilizing electricity. So basically, if you know a little bit about electricity at this point, when you have a positive and a negative flow, you're going to have an arc between the two pieces of metal. Now that arc heats up the metal. This particular metal with this amount of electricity is going to heat the metal up enough to soften it, create a small molten puddle, and allow the stick or the rod to melt into the puddle, so that way you get a bond for your bead. So let's go in, let's talk about basically the stick a little bit. Now there are several sizes of sticks out there that's used. Now these sticks come with a coating on the outside, and these coatings vary. They're very different. Let's go into the number system to help explain things. I have a little picture here where the stick is, you see the number, so a stick would be, this one is 7014, so E7014. E is electrode, and to break down the number, 70 will be the tensile strength, so 70,000 foot-pounds per square inch. Sorry, 70,000 pounds per square inch as far as its tensile strength. Now the 1 that's denoted there, the 1 stands for what position you can weld in. A 1 is all positions. Overhead, vertical, horizontal, it's all positions. As you go along, 2, 3, and so I think 2 and 3, you get to limited positions. It basically starts limiting on what you want, because the way the stick is, it's not going to deposit the metal properly because of how the heat is reacting, the coating that may be on the stick, things like that. So 1, great all positions, especially for beginners. 7014, great stick for beginners. It gives you a nice bead. It's really easy to work with. And then the last number, the 4, basically denoting the type of coating that is on the stick. So if I'll show here just the tip, you'll see the core of the rod, and then you'll see the coating around the outside. Now these coatings are special depending on the weather and circumstances, the material that you're working with, and also the current. If you're running a negative, positive to negative, or negative to positive, depending on the current, all that will be in this last number for the coating. They could be a sodium coating for specific things. There could be a low hydrogen, and basically this coating, when you're welding, will help protect the weld, and I'll get into that. So basically, when you're welding, you're having the rod in the rod holder, in the electrode holder, and you have your negative clamped either to your project or to the table so that you get a electrical transference. You're bringing that rod down, and right here you're going to just strike like a match, just strike the tip, because what you're doing is you're creating a contact and you're getting close enough to cause that electricity to arc and jump, and it'll jump to the metal. So it'll come out from the tip, jump to the metal, and basically start heating up the metal. Now as it's heating up the metal, two things are happening. One, the core is starting to deposit. It'll start to melt away and deposit onto your project. The coating will also start to melt away with it, and will then form basically a slag crust over the project as the metal cools, as you're drawing it down. Now, there are other welding types where they do other things, but this slag, pretty much like a MIG, acts like the inert gas, except instead of having a gas to keep the arc, it's the material being around it limits where the arc can come from, and as that melts into it, like I said, it protects the metal from any other impurities that might be in the area. Of course, because if you're in a very wet area, you want low hydrogen because you don't want anything else igniting, or if you want low sodium or high sodium or something like that, basically helping to protect the weld so that it can cool off properly and be strong and get a proper bond with that metal. Let's go into basically the materials really quick. So we'll have the parts here. You have your ground clamp, which is clamped to the table. You'll have your electrode holder, which will hold the rod. You have the rod itself, which will be different metal alloys that you can use. Most of them are the same, but there are some variables depending on what you're welding. And then you have your transformer, which is basically taking the current, the current that's coming out of the building, and basically increasing it, transforming it so you get enough voltage to pass through. So that's pretty much covers it, as far as that. Now the next thing you want to do is, keeping all that in mind, when you start welding, there are ways to tell if you're doing okay. Not a lot of people put it out there. Very few people do. There's a YouTuber that I watch, I can't recall his name, but he started to finally touch on it, on what a good weld looks like and what a poor weld looks like. So here I have a couple of examples of beads, and these beads will show you basically if you're depositing the material correctly, if your travel is too fast, if your travel is too slow, if the electricity is too high and it's arcing all over and you're getting a splatter, or if it's too low and you're not getting a good penetration in it. So, here's a kind of a sight guide on what it would look like if you're getting a good bead or not. Of course, you're going to experience this over time, and I cannot stress enough about practicing. You have to practice, especially if you're at JTech. Get the scrap material and just lay bead after bead. Do a pad of beads, bead after bead after bead after bead, right next to each other, and just do a pad, and just keep going and keep going. After your first couple of beads, check to see if you're getting the beads right. Once you get the beads, you're getting the proper amount of voltage, the right distance. You got to remember, as you're welding, you're depositing, so you're having to move in closer and closer and closer and closer as it eats up that rod. So you have to not only do travel linear, but you're also having to go down as you're getting closer to the project. So anyway, I know I spoke really fast. That's basics of stick welding. We'll get into my last video where I will discuss MIG and probably touch on a few things from this video. So I'm making these really quick. Again, see you guys around. Thank you for joining me, and take it easy.